Good evening, students. In this video, we will go to discuss about the parabola. What is parabola? Before going to discuss about parabola, we have to go for conic section. What is conic? The locus of a point moving on a plane such that its distance from a fixed point and fixed straight line is in a constant ratio E is called the conic. What is conic? The definition of conic is it is nothing but a locus of a point loc. First we have to discuss about conic. The locus of a point which moving on a plane such that its distances from a fixed point and a fixed straight line the locus of a point which moving on a plane such that its distances from a fixed point and a fixed straight line in the plane are equal or in equal ratio fixed ratio a fixed ratio E is called conic. The locus of a point which moving on a plane such that its distances from a fixed point and a fixed straight line in the plane or in a fixed ratio E is called conic. Okay. In this fixed point is called as focus, generally denoted by the letter S. That means if we draw figure, suppose P x1 y1, xy is a point on the locus. It should be equal distances from a fixed point S and a fixed straight line, perpendicular distance. These two are equal. Let this is M. This is L is equal to the line. And fixed straight line is called directrix and fixed ratio E is called eccentricity directrix, focus. These three are we have to know. What is conic? The locus of a point on the plane moving on a plane such that its distances from a fixed point on a fixed straight line are in a fixed ratio is called the conic. That fixed point is called focus and generally it is denoted by S. That fixed straight line is called the directrix and the fixed ratio E is called the eccentricity. In other words, we can say the definition of conic as if the locus of a point P moving in the plane such that SP by PM is equal to E, constant, where PM is the perpendicular distance from P to the fixed line, fixed straight line, is called conic. The locus of a point P moving in the plane such that SP by PM is equal to E, constant, where PM is the perpendicular distance from the point P to the fixed straight line and S is the fixed straight line such that SP by PM constant. Okay. Here S is the fixed point. Okay. In this way, we can define conic. Here, we have to discuss about E. Here, the ratio of SP and PM is equal to E is fixed. If E is equal to 1, that implies conic is called parabola. If E is equal to 1, then that conic is called as per parabola. If 0 less than E less than 1, the eccentricity lies between 0 and 1, that implies conic is called ellipse. The conditions you have to know, you have to remember. And if E greater than 1, if eccentricity greater than 1, then that conic is called hyperbola. You have to remember, if E is equal to 1, then conic is parabola. If eccentricity lies between 0 and 1, then conic is ellipse, and if eccentricity greater than 1, then that conic is called hyperbola. Okay. Now we will discuss about, this is the introduction of conic sections and about eccentricity, focus, directrix, and regarding eccentricity, we can define parabola, hyperbola, and ellipse. Now we will go to derive a equation to the parabola in general form. Next, equation of parabola in general form. Now we have to let S is equal to alpha comma beta is focus, and equation of directrix is Lx plus My plus n is equal to 0. If we draw a figure, S alpha comma beta, this is L is equal to 0, and P x comma y any point on the parabola. Then by the definition these two are equal. SP by P. By the definition of parabola, SP by PM is equal to E is equal to 1. That implies SP is equal to PM, SP square is equal to PM square. We can find the distance between S and P is known as SP, and PM is the perpendicular distance from P to the directrix. What is this equation? Lx plus My plus n is equal to 0. Then write SP square by using distance formula x minus alpha whole square plus y minus beta whole square is equal to PM square is perpendicular distance. We know that perpendicular distance from x1 y1 to any point to the straight line, any straight line ax plus by plus c is equal to 0. Perpendicular distance d is equal to mod of ax1 plus by1 plus c by root of a square plus b square. By using that, here PM square means here point is x comma y, so ax plus by. Point straight line is Lx plus My plus n, so Lx plus My plus n whole square, because squaring by root of the coefficient of root, there is no need, L square plus n. Okay, this is the general form of the hyperbola with focus alpha comma beta and directrix Lx plus My plus n is equal to 0. Then we call this S a straight line passing through focus and perpendicular to distance. So directrix is called axis of the parabola. Already we have to discuss. Then equation of axis may be axis E, perpendicular straight line passing through S alpha comma beta and perpendicular to Lx plus My plus n, that is m into x minus alpha minus L into y minus beta is equal to 0 is the equation of axis. Okay. In 1D we already know. We know that the equation of any straight line ax plus by plus c is equal to 0 and passing through x1 y1, equation of perpendicular line to given straight line is maybe b into x minus x1 minus a into y minus y1 is equal to 0. By using that we can find the equation of axis. Okay, this is the general form of parabola. Okay. Now we have to go for further point, that is standard form of equation of parabola in standard form. That is very very most important in 7 marks problem. You have to know very well. You have to practice. It will appear in so many exams, so many times in IP exams. That is standard form of parabola. Standard form of parabola. It is very very important concept. You have to know very well. You have to practice. Just standard form of parabola. Equation of parabola in standard form. It is nothing but it is y square is equal to 4x. We have to prove this by using locus, theory of locus, essential and that means necessity and sufficient conditions we have to discuss. Let S be the focus and comma L be the directrix and Z be the projection of S on the directrix L. Then A be the Z be the projection of S on L, and A is the midpoint of SZ. Then we have to draw figure. Let this is directrix axis. This is yes. P x comma y be any point on the parabola. This is given SZ. Then the line y dash is a straight line passing through A and parallel to directrix L. Then since A lies on parabola, A is called the vertex of vertex. Take S A y a y dash z s x. Take ZS as x-axis and YY dash E as y-axis. That implies the coordinates of A is equal to 0, 0, or since this is origin. This is y-axis and this is x-axis. This is A 0, 0. Let S is equal to A, 0, where A greater than 0. A is first. Put S A, 0. Since this is x-axis, on x-axis y coordinate 0, and the distance between A to S is A, and SA, since SA is equal to AZ, then Z is equal to minus A, 0. That implies the coordinates of Z is equal to minus A, 0. Okay, that implies equation of directrix is x is equal to minus A or x plus A is equal to 0. This is the equation of directrix. Now take P x comma y be any point on locus, then by the definition Sp by Pm is equal to E is equal to 1. That implies Sp square is equal to Sp is equal to Pm. That implies Sp square is equal to Pm square by squaring on both sides. What is Sp? The distance between S and P is by finding x minus A whole square by using distance formula plus y minus 0 whole square is equal to Pm square, means the perpendicular distance from P to the line directrix. This is x plus A is equal to 0. The equation of directrix is x plus A is equal to 0. Already I explained. Then what will be the perpendicular distance Pm? Pm is nothing but the mod of Ax1 plus perpendicular distance from any point Px1, y1 to the Ax plus By plus C is equal to 0 is mod of Ax1 plus By1 plus C by root of A square plus B square by squaring. So we can write here x coefficient is 1 into x plus there is no y term, so y term does not taken. So x plus A by root of 1 square plus 0 whole square, that is equal to x plus A whole square. There is no need to write this much this term. That directly we can write x plus A whole square. That is x square minus 2ax plus a square plus y square, y1 0 is y, is equal to x square plus 2ax plus a square. By simplification, x square get cancelled, a square get cancelled. What is remaining? Minus 2ax plus y square is there. Y square is equal to, if we bring this minus 2ax that side, 2ax plus 2ax, that is 4ax. This is the locus of the point P with the given data. This is the necessary condition. Conversely, we will take Conversely, if P is any point, P x y B any point such that y square is equal to 4ax. That means P belongs to y square is equal to 4ax. That implies therefore SP is equal to, by distance formula we can find x minus a whole square plus y minus 0 whole square, that is equal to x square minus 2ax plus a square and the root plus y minus 0 whole square is y square. Instead of y square we can write 4ax y square. Here it is equal to x square minus 2ax plus a square plus 4ax by using 1. That is equal to x square plus 2ax minus 2ax plus 4ax plus 2ax plus a square. This is nothing but x plus a whole square. This is nothing but mod of x plus a. Mod of x plus a is nothing but, here the distance from z to a is a, and if we, the coordinates of P, this is x1, that is different, here suppose this taken, this is x, the total Zn is equal to Pm is equal to a plus x is equal to, a plus x is nothing but Pm is equal to Zn. That implies Pm is equal to x plus a. Instead of x plus a, we can write Pm. This is the sufficient condition to the standard form of parabola. So, if we take Px comma y and parabola, then it satisfies y square is equal to 4ax. If P is any point on the satisfying y square is equal to 4ax, then it satisfies Sp is equal to Pm. That is the definition of parabola. That means Sp is equal to Pm means Sp by Pm is equal to 1 is equal to E. So that is the definition of parabola. It satisfies. So sufficient and necessary conditions are true, both are there in this proof. Thus, the standard form of parabola may be taken as y square is equal to 4ax. It is very, very important proof. You have to practice very well and then attempt in exam if it appears, if it occurs. Okay, best of luck.